Today we'll learn in detail about metals and non-metals, and we will be covering topics physical and the chemical properties of metals and non-metals, reactivity series of metal and the reaction between metals and non-metal, that is formation of ionic compound, and properties of ionic compound, occurrence, extraction and refining of metals, and the last topic, corrosion and the prevention of corrosion. So you must have studied in your ninth grade about different elements, and 118 elements are known to us. And in the periodic table, we have classified these elements into different categories like metals, non-metals, metalloid, and the radioactive element. Okay. And these elements, all 118 elements, are classified on the basis of difference in their physical and the chemical properties. Okay. So out of these, metals and non-metals will study in detail. And what are metalloids? Metalloids are those elements which are having property which are intermediate between the properties of metals and non-metal. That is, they are neither purely metal nor non-metal. And the radioactive elements are those unstable elements which show the process of or phenomena of radioactivity, that is emission of highly energetic penetrating radiation, that is alpha, beta, gamma rays. So we'll start with the first one, physical properties of metals. Okay, now always remember to compare elements on the basis of physical property is very easy. That is, we can tell the difference on the basis of how we feel, what we see, or what we experience. And the further differences we study on the basis of chemical properties. So physical property, the very first one, all of us know that metals, they exist in the solid state, that is, they are solid at room temperature, and the only exception in this case is mercury, which is liquid. You have to remember symbol of different elements, so make a list of symbol of different element, and so that you are not getting confused with the same in your exam. Second physical property is that all metals, they have metallic luster. That is, all metals, they shine, and we know that metals are used in making jewelry like silver and gold. So the metals which are having very good luster or shine are gold, silver, platinum, iron, copper, and aluminium. Next is, metals are hard and tough. That means you cannot press with hand or with the very small force. Lots of force is needed, and they will retain their shape we cannot change. And here the exception is of alkali metal. Alkali metals of first group, that is lithium, sodium, potassium, etc. And these metals, that is alkali metals, they are so soft that we can cut them with knife. Okay, so they are very soft. This is the only exception. Except alkali metal, all metals are very hard and tough. Metals are malleable. That means if we beat them with a hammer, we will get a very fine thin sheet of metal, and metal will not break into pieces. This is called as malleability. And the most malleable metals are gold and silver. Other elements which are having, or metals which are having malleability to a good extent, are iron, aluminium, and copper. Okay, therefore aluminium sheet or iron sheets are used for construction. And the next is ductility, or metals are ductile. That means we can make very thin wires out of metal, and again they will not break into pieces if we are applying force to make wire. And the most ductile one is gold, and this is what we can make a very fine jewelry of gold, because it is highly ductile. Other which are also ductile are silver, copper, and aluminium, and therefore these three are used in making electrical wires. Okay, metals are good conductor of heat and electricity. You know this very well. In your kitchen, different appliances or the utensils are being used. Why? Because metals are good conductor of heat and electricity, and when we heat them, they will not melt easily. Therefore they have high melting point. And this is also one of the reasons that they are used for making cooking utensil. Okay, and best conductor of heat are silver and copper. And here we are having one exception. Gallium and cesium are exception that they have very low melting point. Otherwise, all metals are having very high melting point. So this is the exception. Okay, exception is of gallium and cesium. Rest, they have high melting and boiling point. Next point is they are good conductor of electricity. You know electrical wires are made up of metal. So here most conductive are the copper, gold and silver. Now metals, when we hit surface of metal with something hard, they produce sound. That means they are sonorous. They produce sound, and the metals which are capable of producing sound are copper, aluminium, silver and iron. Therefore, in school, bells are made up of copper or iron. And your musical instruments are mostly made up of copper or the alloys of copper. Next, physical properties of non-metals. So these were the physical properties of metal which separate them from the non-metals. And in your periodic table, your metals are on left hand side and the non-metals are on extreme right hand side. Metals are many, but non-metals are very few. So non-metals are either solid, like for example in case of carbon and sulfur, they are solid. Carbon is black solid and sulfur is the yellow colored solid. And they are gases like hydrogen gas, oxygen gas, nitrogen gas and helium. Here I am not showing the formula of the gases. I am only depicting here the symbol of the element. Okay, so don't get confused with that. If you write the formula of gases, it will be H2, O2, N2 and like that. Except bromine. Only bromine is a non-metal which is liquid. Otherwise, they are either solid or gases, mainly gases. So it include the element on right hand side, which include your noble gases as well as the halogen. Now non-metals are non-lustrous or they are very dull. You know that carbon in the form of coal or coke, it is having dull appearance. It is not having shiny appearance like metal. And the only non-metal which is having a shine or luster is iodine. It is having that whitish shine just like metal. So this is the only exception. Now non-metals are neither tough nor strong like metals. And here exception is of diamond. Diamond is very tough. It is hardest known substance and it is one of the allotrope of carbon. Carbon exists in different allotropic forms, diamond and graphite, and here diamond is the hardest known substance. So in all categories of physical properties of either metal or non-metal, you have to remember the exceptions. Non-metals are brittle. That means if we hit them with a hammer or apply force, they will break into pieces. That means they are non-malleable, they are non-ductile. We cannot press them or hit them to make sheets or wires. They will break into small pieces if we hit them hard with a hammer. Non-metals are bad conductors of heat and electricity. Okay, and here exception is of graphite, another allotrope of carbon. Graphite is a very good conductor of electricity as well as good conductor of heat. Therefore, graphite is used for making electrodes in electrical appliances. Next, non-metals have low melting point and low boiling point. You know, melting and boiling point is low. Therefore, many of them are gases. Okay. So here again exception is of diamond. Diamond, what is diamond? It is basically carbon. So diamond is having very high melting and boiling point. So these are the physical properties of metals, and always remember that the easiest way to start grouping substances is by comparing their physical property. As I told earlier, we can separate them, but with surety we cannot say. Therefore, here comes the role of the chemical property, okay, because there are many exceptions, so we will be confused that element is a metal or a non-metal. As a result of this, we will focus on chemical properties also, and combinedly with physical and the chemical properties that we will observe and study, we will categorize them as metal or non-metal. So purely physical property cannot classify any element as a metal or a non-metal. Now, chemical properties of metals. Chemical properties of metals are divided into different sections. You have to remember the reactions in each category. The very first one is reaction of metal with oxygen. Okay, you know, in our atmosphere, we breathe air, and along with air we take in oxygen. So we are having oxygen in our atmosphere, as well as oxygen is very abundant in our earth crust also in the form of different compounds. Metals, they react with oxygen, and therefore these metal compound in the form of oxides are present in the earth crust, and oxygen is highly reactive. So metals react with oxygen to form metal oxides, a class of compound, and these metal oxides, when they react with acid, they form salt and water. Okay, you know, acids reacts with bases to form salt and water. So when metal oxides are reacting with acid, that means metal oxides are what? They are basic in nature. So always remember, when metal react with oxygen, they form oxide, and these metal oxides are basic in nature, okay, or they act like a base. Now, always remember another idea, that different metals react with oxygen at different rate, because different metals, they have different affinity or reactivity for oxygen or any other reagent. Okay, because all metals are not having same reactivity. So different metal react with oxygen at different rate. So how we can make this difference? We can do it with different metal, how they react with oxygen. The first one is, so most reactive metal like potassium and sodium, symbol for potassium is K, symbol for sodium is Na. These are metals of first group, and these metals are very, very reactive. They react vigorously, and reaction is so fast and violent that your metal will catch fire if we keep it in open air. That is, it will catch fire, or it will react with atmospheric oxygen at normal temperature without heating, without doing anything. And therefore potassium and sodium metal, they are always kept immersed in kerosene oil, so that they are not coming in contact with oxygen. So here kerosene oil is acting as a barrier between the metal and your atmospheric oxygen. So here is the formula of metal oxide, that is sodium oxide. Now, how to write the formula of any compound? This idea you already know. Sodium has got valency 1 and oxygen has got valency 2. So we will cross multiply the valencies. Therefore, formula is Na2O. Okay. Next is magnesium. Magnesium burn in air with dazzling white flame. Sometimes they give you a question with the observation and the condition, so you have to guess what will be the product. So sodium metal react without heating, without doing anything at normal temperature, and its reaction is very fast. But in case of magnesium, magnesium will not react with oxygen at normal temperature. We have to heat, and once we start heating, it will catch fire and it will burn with a very dazzling white flame, just like we have in case of crackers. And we will get a white solid. This is magnesium oxide, which is white in color. Okay, so white powdery substance is basically magnesium oxide. This magnesium oxide is solid. Okay, now next is aluminium. Now in case of aluminium, reaction is further slow. So aluminium will react only when it is heated strongly to form aluminium oxide, and this is the formula. Again, I am showing you how to write down the formula of aluminium oxide. Your aluminium has got valency 3 and oxygen has got valency 2. So we will cross multiply the valencies, and therefore formula is Al2O3. So this is aluminium oxide. Now one thing that you have to remember, that in case of aluminium, magnesium, zinc and lead, okay, when they are exposed to atmosphere, so at normal temperature, they also form a protective layer of oxide, and this oxide layer will prevent further oxidation of metal. Okay, so you must have seen at home that the utensils which are like your saucepan, which are used for cooking, new aluminium vessels are very shiny, like a silvery look is there, but when we use for some time, they look dull because of this, the formation of a protective layer of oxide, that is layer of aluminium oxide. and this will prevent further oxidation of metal. Okay, so in case of aluminium, slow process of protective layer formation is also there in addition to formation of aluminium oxide on heating. Next, copper. Copper will not burn. If you heat it, it will not burn. But if we heat strongly for a long time, then metal develop a coating on its surface which is black in color, and this coating is of copper second oxide. Copper second oxide means copper is having valency 2. Copper can have 2 valencies. First valency is 1, that is copper first oxide, for example, and second valency is copper second oxide. So in Roman numerals, whatever number is written, that is the valency of that element. So copper exists in 2 valencies. Why? Because it is a heavy metal, and most of the heavy metal or transition metals show more than 1 valency, like iron also. So in case of copper, we will show the reaction. Copper will react with oxygen to form copper oxide, and this copper oxide react with acid to form salt and water. That means this copper oxide is basic in nature. This is a basic oxide. So here we can show the physical state of all element. Copper is solid, oxygen is gas. In subscript show the physical state, and copper oxide is also black colored solid. This black color solid, when treated with HCl, mostly the dilute HCl, that is aqueous form, we will get a salt, CuCl2 and water. So second reaction is a proof that your metal oxides are basic oxide, because they react with acid to give salt, just like bases react with acid to give salt. Next idea. After this, iron does not burn on heating. That means you must have seen at home we have kadhai or pan made up of iron. So even if we are cooking for a long period of time, they will not burn. Okay. But if we have very thin fine strip of iron that we call as iron filling, if we burn them on flame, they will catch fire. Okay. And this is why, because of the large surface area. When we make very fine particles, so reaction is faster. Therefore, sometimes for few reactions, solid is converted into powder, so that reaction is faster. Next, silver and gold, they will never react with water, whatever is the temperature. So what we can say, out of all these observations that we have seen here, most reactive is sodium, then magnesium, then aluminium, then copper, and then your iron, and in the end we have silver and gold. So on the basis of reaction with the oxygen, we can show how different metals are having different reactivity. Now, few points you have to remember in case of oxides. Okay, we are saying metal oxides are basic in nature. We can prove this in another way. Some metal oxides which are soluble in water, remember the idea that most of the oxides are insoluble. Okay, very few are soluble in water. So those metal oxides like your sodium oxide and potassium oxide, they are soluble in water. So when these metal oxides, they are treated with water, they will dissolve to give you hydroxide, and like sodium hydroxide and potassium hydroxide. And these sodium hydroxide and potassium hydroxide solutions are nothing but they are called as bases. Okay. And those bases which are soluble in water, they are called as alkalis. So therefore, these metals like sodium and potassium are called as alkali metal. Why? Because when they their oxides are dissolved in water, they form bases which are called as alkalis. Okay. So this reaction is again a proof that your metal oxides are basic in nature. Therefore, when they are dissolved in water, they form bases. Out of all metal oxides, few oxides, they are having a special nature, that is they are amphoteric oxides. Why? Because these metal oxides, they can react both with acid as well as bases. We have seen Metal oxides are here. We have shown here metal oxides are basic oxide. Therefore, they react with acid to give you salt and water. But these amphoteric oxides, they can react with both acid as well as base to produce salt and water. And this property of any oxide where it can react with both acid as well as bases, these oxides are called as amphoteric oxide, and the property is called as the amphoteric nature. And two examples of reaction I have shown here for aluminium oxide. Aluminium oxide and zinc oxides are amphoteric oxide. So here I have shown here aluminium oxide, when we treat it with acid, it will form a salt that we called as aluminium chloride. Okay, and when the same aluminium oxide is treated with a base, it will form again a salt that we called as sodium aluminate and with some water. Now here in the first reaction, aluminium oxide is acting as a base and or basic oxide, and here it is acting as an acidic oxide. Okay. One thing that you have to be very clear, I'm showing here. It's important to write down the correct formula for the compound like aluminium chloride or sodium aluminate. So I'm showing here how to write down the formula. For aluminium, we have valency 3, and for chlorine, we have valency 1. In case of metal, always remember whatever is the valency, it is the charge on metal. So basically, we are having 3 unit positive charge in case of aluminium and 1 unit negative charge in case of chlorine. So therefore, we will cross multiply the valency, or we will balance the charge because molecule is neutral, and therefore formula is AlCl3. Okay, now we'll write down for sodium aluminate. Sodium aluminate is a complex salt which is having two metals. But again, the idea or the concept of electrical neutrality will be applied here. Sodium is an alkali metal. It is having 1 unit positive charge. Aluminium is having 3 unit positive charge. And oxygen has got 1 unit negative charge. So valency of oxygen is 2. For sodium it is 1 and for aluminium is 3. So therefore total positive charge is 4 unit. Okay. 4 plus. And to balance 4 unit positive charge, we need 4 unit negative charge. So therefore we will take 2 ions of oxygen, because 1 ion of oxygen will have 2 unit negative charge. So this is how formula is Na, 1 atom of sodium, 1 atom of aluminium, and 2 atoms of oxygen, O2, because we are doing twice here. So I hope this is clear. Now come to the next reaction, that is reaction of metals with the water. Different metals, they react at different rate with water, just like their reaction with oxygen or air. And metal react with water, and first they will form metal oxides and hydrogen gas is liberated. Okay, and these metal oxides, if they are soluble in water, they will dissolve in water to give metal hydroxide. Remember, most of the metal oxides are insoluble, so they will not form hydroxide. Hydroxides will be formed only by the alkali and the alkaline earth metal oxide, that is first and second group metals. Okay, so hydroxides are what are hydroxide? Hydroxide are nothing but they are the bases. Hydroxide is a base. Okay, basic compound. So let us see the example. First is the most reactive one, that is potassium and sodium. They react very violently with cold water. Okay, and the reaction is so violent that large amount of energy is released, and therefore we call it as the reaction is highly exothermic, and hydrogen gases evolve, and as soon as gases evolve, it will catch fire, and therefore reaction is highly violent. Okay, and it is very difficult to control. So usually in lab we do not do this reaction. There will be a blast just like a bomb. So the reaction is why sodium and potassium, they are highly reactive. Therefore sodium will react with water. First it will form sodium oxide and then hydroxide. So I am showing here directly the formula of hydroxide. Okay, why? Because sodium oxide is soluble in water. Therefore it will form finally hydroxide. and here large amount of heat is liberated. Therefore we are calling these reactions as your exothermic reaction. Same is in the case of sodium. Hydrogen gas is liberated and heat is evolved. So these are both are what bases, or we call them as alkalis also. Now in case of calcium, reaction is quite good, but it is not that violent as in case of potassium or sodium. Therefore calcium is less reactive towards water, and here again, being an alkaline earth metal, it will react with cold water to form hydroxide. Reason, oxide is soluble in water, like calcium oxide is soluble in water, therefore it will dissolve in water to form calcium hydroxide. In case of magnesium, reaction is not possible with at normal temperature or with cold water. It will react only with hot water. That means reactivity of magnesium is a bit less, and we will again get magnesium hydroxide. Reason, alkaline earth metal, so oxide is soluble. So out of these four reactions, I have shown you here four equations. What idea you have got from these four? That means first one, in case of potassium, we'll get potassium oxide. In case of sodium, we will get sodium oxide. In case of calcium, we will get calcium oxide. And in case of magnesium, we get magnesium oxide. So these are the oxides which are soluble in water. Therefore, we are showing here directly the formula of their what you call hydroxide. Okay, we are not writing the formula of oxide. Now come to the other element of less reactivity, like aluminium, iron and zinc. They will not react even with hot water. They will react with steam to form oxide. Okay, we will not get hydroxide here. Why? Because these two are insoluble in water. So they will not dissolve in water. So no hydroxide formation there. Fine. And the last one is lead, copper, silver and gold. They will not react with water. Remember the formula. Pb is lead, this is copper, this is silver and this is gold. So different metals have different reactivity with water. Most reactive are potassium, sodium, calcium, and the least one are lead, copper, silver and gold. Next reaction, reaction of metal with acid. So metals react with dilute acid to give you salt, and hydrogen gas is liberated. And this hydrogen gas will be liberated in the form of bubbles. So on the basis of intensity of bubbles and how fast bubbles are formed, we will get how reactive is the metal. So here magnesium will react with hydrochloric acid to give magnesium chloride. Hydrogen gas is liberated and heat is evolved. And therefore very fast bubbles we have in case of magnesium. Therefore most reactive is magnesium. And the bubble formation for the hydrogen gas is slowest in case of hydrogen. That means what we say, as we come from magnesium to iron, reactivity of these metal decreases. Okay. Remember to write down the formula of these compound as we did earlier on the basis of valency of metals. Now next is hydrogen gas. Hydrogen gas is not evolved when metal react with nitric acid. Okay. With hydrochloric acid, we'll get hydrogen gas as one of the byproduct. But in case of nitric acid, we'll not get. Why? Because nitric acid is a strong oxidizing agent. So it will oxidize hydrogen which is produced to water. So in place of hydrogen, we'll be getting water there. Okay. Here are two exceptions, but magnesium and manganese react to evolve hydrogen gas. So this is when magnesium react with nitric acid, which is oxidizing agent also. It will form magnesium nitrate. Okay. Nitrate. How to write down the formula for magnesium nitrate? Magnesium is alkaline earth metal. Valency is 2, or it has 2 unit positive charge. Nitrate is polyatomic anion with 1 unit negative charge. Okay. So here we have 2 plus. Here we have a single unit negative charge. So here we will write 1 as the valency, and when we cross multiply the valency, we will have formula MgNO3 whole twice. So this is magnesium nitrate. Now next is copper. Copper will not react with hydrochloric acid. Reason? Metal of low reactivity. Now reactivity on the basis of these reactions, how we relate the reactivity, potassium is most reactive and the least one is iron. This is reflected on from the how fast and how much bubbles are formed when hydrogen gas is liberated in each case. But one more parameter is there which will decide the your reactivity of metal, and that is the temperature. When potassium will react with acid, we will get highest temperature of the medium, while in case of iron will get lowest temperature. What is the idea of this highest and the lowest temperature? So have a look here how we do this reaction in lab. We will take a test tube, and in this test tube we will take the required metal. Suppose this is the piece of required metal for it, and in this test tube we will put a thermometer just to check the temperature of the medium. Okay, so this is your thermometer, okay, to check the temperature. Now we will add your acid in this. So we will be adding acid and a reaction will take place. So temperature of the medium will increase. Why? Because it is exothermic reaction, because heat energy is liberated, and this temperature is noted down on your thermometer scale. So from the thermometer scale, what we have found that the highest temperature is attained in case of potassium, because reaction is highly violent and therefore exothermic also, while the lowest temperature is we get in case of iron. So from any reaction, by the reaction of the medium also we can decide that how efficient or how fast the reaction is. So for sodium and potassium, reaction is so vigorous and it is highly exothermic that even with cold water, that we usually do not do this reaction in lab. Metals like gold and platinum, they will not react either with dilute or the concentrated acid. Why? Because they are having the inert behavior. So if we want to dissolve your gold or platinum, we have to use something special which is capable of oxidizing them, and these inert metals, they will react with a special liquid that we call as aqua regia, or we alternatively call it as royal water. What is aqua regia? Aqua regia is highly corrosive and fuming liquid, okay, and it contains concentrated hydrochloric acid, 3 parts of concentrated HCl, and 1 part of concentrated nitric acid. So when we mix these two, so freshly prepared mixture is called as aqua regia, and we can treat your gold or platinum with this, and we can dissolve them in this liquid. Otherwise, no other acid is capable of dissolving gold and platinum. This metal is gold and platinum. Next reaction with the solution of other metal salts. So always remember that more reactive metal displaces less reactive metal from its salt solution or molten form. Molten form means liquid form. Liquid form of any metal, how we attain? We heat metal to a temperature which is higher than its melting point, so it will melt into liquid. That is the molten form. So metal A in our case here is more reactive. Therefore, this metal A will displace metal B from its salt solution, and we will be getting solution of metal A, and metal B will get reduced. Okay, now here I have given you here 4 examples of different combination of metal and the salt solution. So the first one, iron when treated with copper sulfate solution. So iron here I have shown in the this test tube, we have taken an iron nail and we have taken copper sulfate solution, which is aqua blue in color, and this assembly we leave for suppose 15 to 20 minutes. We will keep it untouched for 15 to 20 minutes. What we will observe after 20 minutes, that the medium has changed from aqua blue to apple green color, and there is a settlement of some brownish black dust at the bottom of the test tube, and your nail is a bit thinner. Okay, so what reaction is taking place here? Your iron, being more reactive, will displace copper. That means copper is kicked out. It is just like the law of nature that anything which is stronger will dominate on the weaker one. So here, stronger or the more reactive metal will kick out the less reactive metal from the salt solution, and as a result will get the your less reactive metal in the solid form. That is, here we are getting a reduced form of copper. Okay, and your color changes. Why? Because copper sulfate is aqua blue in color, crystals are aqua blue color, while your ferrous sulfate is light apple green color. Sometimes due to impurity we get creamish shade also. So this is first reaction. So from this reaction, what idea we are getting here, that iron is more reactive than copper. Therefore, iron is capable of displacing copper from copper sulfate. Now second reaction. In the second reaction, we have taken now iron sulfate solution, that is green, apple green color solution, and here we are having a copper wire. Okay, and we keep this assembly again for 15 to 20 minutes. What we observe, there is no change. No change. Medium remain as such. That means what? We are not having any reaction in this case. And why? Reason is that copper is less reactive than iron. Copper is less reactive than iron. Therefore, copper is not capable of displacing iron from its salt solution. So, a weaker person is never able to express his idea correctly. Why? Or weaker person is not able to do what he wants. Why? Because the stronger one will dominate. So, the next reaction, the third one. In the third reaction, we have taken again copper sulfate solution, which is aqua blue, and this time we have dipped zinc metal or zinc strip into it. We keep assembly for 15 to 20 minutes, and after this time, what we found, that medium is now colorless. Okay, so from aqua blue we are getting colorless solution of what? Why we are getting colorless solution? And there is again deposition of some brownish black dust at the bottom of the test tube. Okay, and there is no strip of zinc metal. So what is happening in this case? In this case, zinc being more reactive will kick out copper or will displace copper, and we will get the copper metal and zinc sulfate solution, and zinc sulfate solution is colorless. Okay, therefore medium is turning colorless here. So from this, what idea we are having? Zinc is more reactive than copper, therefore it is capable of displacing copper from its salt solution. Next idea, this time we have taken iron sulfate, that is apple green solution, and we have dipped again the zinc strip. So after some time, what we observe? We will be getting again the same thing, colorless solution, and here again we are getting a colorless solution. Okay, and this time there is some blackish or grayish dust at the bottom. This dust is nothing but what is your iron metal at the bottom. So from the fourth reaction, what idea we are having? That zinc is more reactive than iron also. So out of three metals, most reactive is zinc and the least reactive is copper. Therefore, on the basis of these displacement reactions, we can arrange these three metals in this order of their reactivity, from most reactive to the least reactive one. In case of displacement reaction, one thing which is important to remember the observations which I have explained with the help of these test tubes. So do remember how color changes either from aqua blue to green or aqua blue to colorless. Accordingly, compounds are formed. So this is all for displacement reaction. Now displacement reaction will give you a new idea or a new concept of the reactivity series. Here we have seen we can arrange metal in the order of their reactivity like this. So your reactivity series is a list of metal arranged in the order of their decreasing reactivity from most reactive to the least reactive. So here most reactive metal like alkaline earth metal like potassium, sodium, calcium are at the top, and at the bottom we are having the least reactive metal like gold. In the middle we have placed hydrogen also to compare the reactivity. So what idea you should remember that those metals which are above hydrogen, they are capable of displacing hydrogen from acid, and those which are at the bottom below hydrogen, they cannot displace hydrogen from the acid, so they will not react with the solution of acids. Okay, second idea, the metal which are at a higher level, like for example zinc, can displace a metal which is at a lower level from its salt solution. Therefore, zinc will displace copper from copper sulfate, and therefore zinc sulfate is formed. So more reactive metal is which is at a higher level will displace less reactive metal, like same in the case of iron and copper. So this is reactivity series. You should remember this arrangement of metals. So learn it as such, because in exam it will be helpful in case of different reactions also. Now next is chemical properties of non-metal. We have discussed now all chemical properties of metals. So we will do for non-metals also, but not so much in detail. Very few reactions you have to remember. The first one is reaction of non-metals with oxygen. We have done that metals react with oxygen to form basic oxide, but a non-metal will react with oxygen to form non-metal oxide, which are acidic oxide. So the very first difference between metals and non-metal is that metal form basic oxide while non-metal will form acidic oxide. Why we are saying acidic oxide? Because when these non-metal oxides, they are treated with water or they are dissolved in water, we will get acids or acidic solution. Or when these non-metal oxides are treated with base, we will have acid-base reaction, therefore we'll get salt and water. So here non-metal oxide is acting as a base, therefore acid-base reaction we will have and will get salt and water. So these two reactions confirm that non-metal oxides are acidic oxide. Now, very few non-metal oxides are neutral also. What is the meaning of neutral? Neutral means neither acidic nor basic. Okay. So, they will not have any reaction with acids or bases. So, don't get confused this with amphoteric oxide. Amphoteric oxide are capable of reacting with both acids and bases, while neutral oxide, they do not show any reactivity either with acid or base, or they are neither acidic nor basic. Okay, like for example, oxides of nitrogen and hydrogen are neutral. Like oxides of hydrogen is what? Water, H2O or N2O. These are your neutral oxides. Now come to how we will show with the reaction the formation of oxide. So when carbon or coke is burned in the presence of oxygen, we'll get carbon dioxide. So carbon dioxide is what? Carbon dioxide is acidic oxide. Carbon dioxide is an acidic oxide, and this acidic oxide will dissolve in water to give you carbonic acid. This is why we are saying they are acidic oxide, because they will form acid. While your metal oxides are basic, they will dissolve in water to form hydroxide, which are bases. Next, sulfur will burn in excess of air to give you sulfur trioxide, and this sulfur trioxide will dissolve in water to give you sulfuric acid. Okay. So these two reactions are confirmation that the non-metal oxides are acidic oxide. Now next is a reaction with water. Non-metals, they do not react with either water or they do not react with acid. Okay, we will not have any reaction, and the basic reason is that non-metals cannot donate electron to form hydrogen gas from H plus ion. Okay, so non-metals, they are electron acceptors. They never give electron like metal, and when they do not give they do not give electron, they are not capable of forming hydrogen gas. So you remember in case of acid, for example, we show here hydrochloric acid solution. So what is hydrochloric acid solution? We will have H plus ion and Cl minus ion. Okay, and when these we treat with a metal like, for example, sodium. Okay, so sodium will convert to Na plus ion, and this Na plus ion will combine with Cl minus ion to give you NaCl, and this hydrogen, we will get NaCl, and this hydrogen H plus ion will take electrons lost by sodium to give you hydrogen gas. So this is how hydrogen gas is liberated when an acid react with any metal. Why? Because when metal form its ion, it will remove electron. So this electron lost here, electron lost by metal, will be taken up by the hydrogen to liberate hydrogen gas. So metals are capable of giving you hydrogen gas, but such type of hydrogen gas liberation is not possible in case of non-metal. Why? Because non-metal, they cannot donate electron to form hydrogen gas, just like sodium. Fine. So therefore these two reactions are not possible, but hydrogen is not capable of liberating your non-metals are not capable of liberating hydrogen, but they are capable of reacting with hydrogen. So non-metals will react with hydrogen to form hydrides. Like, for example, H2O is a hydride, your hydrogen sulfide gas, ammonia gas, and hydrogen chloride gas. All these are hydrides of non-metal. That is, they are formed by the reaction of non-metals with hydrogen gas. Next is reactions of metal with non-metal. Till now, we have done reactions of metals and non-metals separately. Now we will discuss what will happen when a metal will react with non-metal. So before writing down the equation, understand few things, and only then we will be able to decide what type of reaction it will be. You have done in grade 9 that cause of chemical reactivity of any element is the tendency to attain completely filled valence shell, just like noble gases. Noble gases or the inert gases are what? They are not reactive. Why? Because they are having stable configuration, or they have octet condition except helium. Okay. So every element try to get this type of configuration so that it will get stabilized. So cause of chemical reactivity is what? Is to attain completely filled valence shell. Valence shell means outermost shell. Now have a look here in case of metals. I have given here list of metals. These metals, they have 1, 2 or 3 electrons in their valence shell. Have a look here. They are having 1, 2 or 3 electrons in their valence shell. And if these metals want to get a completely filled valence shell, only possibility for them is to lose these electrons. Okay, because if you are having 1 electron, like in case of sodium in outermost shell, so gaining 7 is not easy, but losing 1 is easier. Therefore, it is easier to lose electron to form cation. Cation means positively charged ion, and they will get stable noble gas configuration. So metals are therefore called as electropositive element because they will lose electron to form positive ion. Therefore, they are called as electropositive. Non-metals are electronegative. Why? Because in case of non-metals, we have 5, 6 or 7 electrons in the valence shell. Have a look here. In case of nitrogen, we have 5, oxygen 6, fluorine 7, phosphorus 5, sulfur 6 and chlorine 7. So non-metals, they have large number of electrons. Therefore, it is not easy to lose 5, 6 or 7 electrons. It is easy to take 1, 2 or 3 electron to get octet condition, or 8 electron. So it is easier to accept electron to form anion. Anion means negatively charged ion to get stable noble gas configuration. Therefore we say nonmetals are electronegative element. So when an electropositive element is coming in contact with the electronegative element, what will happen? So when metal react with a non-metal, they have a give and take relationship between them. Give and take relationship. Give and take relationship means what? That your metal will give electron and non-metal will accept electron or will take electron, and therefore a metal will give its valence electron to non-metal and form cation, and the non-metal will accept electron in the valence shell to get octet and form anion or negatively charged ion. And these ion which are formed, these compounds which are formed by the transfer of electron from a metal to a non-metal are known as ionic compound. Okay, so these cations, that is your positively charged ions, and anion, that is negatively charged ion, they will attract each other and therefore they will form compound which we call as ionic compound or electrovalent compound. And here we are having two examples from your NCERT book. So first is the formation of sodium chloride. So sodium chloride, how it is formed? Sodium has got 11 electron because atomic number is 11 and they are arranged so valence shell is having 1 electron. Therefore sodium will lose electron. This 1 electron is lost and it will form Na plus ion or cation with a stable configuration. How we are getting positive charge? Because earlier sodium was having 11 proton and 11 electron, but now 1 electron is lost, therefore only 10 electrons are left. So 10 unit positive charge and 11 unit positive charge and 10 unit negative charge will give you net 1 unit positive charge. This is how we are getting a positively charged ion. Now loss of electron is called as oxidation. So this is oxidation reaction. Next is formation of chloride ion. Now chloride ion, the electron which is lost from sodium will be gained by chlorine. Why? Because chlorine is having 7 electron in valence shell. So it is in a need of only 1 electron. This electron it will get from sodium. It will form chloride ion with a stable configuration. Why we are getting negative charge? Because 7 protons are balanced by what? Only 7 electron, 1 electron is extra, 18 electrons are there, therefore we are getting 1 unit negative charge. Now positively charged ion of sodium will be attracted by negative ion, therefore we have electrostatic bond or ionic bond formation, which is a very strong force of attraction, and we will get the formation of ionic compound, that is sodium chloride, which we call as common salt or the table salt. This one thing which is important to remember here is sodium chloride does not exist as a molecule like HCl. Why? Because it is an aggregate of oppositely charged ion. Large number of positive ion are surrounded by large number of negative ion, and large number of negative ion every negative ion is surrounded by large number of positive ion. So we will get a crystal, a 3D crystal, and a network of positive and negative ion. Okay, so when we write sodium chloride, basically it is better to write it like this: Na plus Cl minus, and we have n number of ions of sodium and chlorine. Next is formation of magnesium chloride. Magnesium has got atomic number 12, therefore configuration is 282. There are 2 valence electron. Okay, so magnesium has to remove 2 electron to get octet condition, therefore it will kick out 2 electron and it will get stable configuration for neon gas. Okay, and we have formation of chloride ion just like we did in the last case. One chlorine atom is in a need of 1 electron, therefore it will take 1 electron to form chloride ion, but what we have, one magnesium is losing 2 electron. Therefore, to adjust 2 electron, we have to have 2 atoms of chlorine, so that 2 electrons are used up, which are lost by magnesium, and we'll get the formation of 2-chloride ion. This is how we are having the formula MgCl2. So 1 atom of magnesium is capable of giving 2 electrons. So 1 electron it will give to one chlorine atom, second to the second chlorine atom, and therefore we will get the compound MgCl2. Okay, so per chlorine atom we are having 1 electron from magnesium, but to balance 2 unit positive charge we are having 2-chloride ion. So this is how magnesium chloride is formed. I am showing you here the your Lewis structure of aluminium chloride also, so that it is more clear to you. So don't get confused. In case of aluminium, we are having 3 electrons in the valence shell. So 3 electrons are there, and chlorine is having 7 electron. So in the Lewis structure we show only the valence electron. Okay, so chlorine is having 7 valence electron. Here we have shown, and this is the third chlorine atom. 1 2 3 4 5 6. Fine. So now this one electron will go to one chlorine atom to form ion, second to second chlorine, and third to third chlorine. Therefore we'll be getting the formula Al, which will be having 3-unit positive charge. Okay, and all 3 electrons of aluminium will be lost, and these will be taken by chlorine. So chlorine already it is having 7, and the 8th electron is from aluminium. So we are having 1 unit negative charge here, and 3 chloride ions are there. So formula of aluminium chloride is AlCl3. Next, properties of ionic compound. Ionic compounds are made up of oppositely charged ion, and there is a strong electrostatic force of attraction. Therefore, ionic compounds are very hard solid, very tough. Reason: strong force of attraction between oppositely charged ion, that is positive and the negative ion. But these are hard and tough, but they are not malleable or ductile like metals, so they are brittle solids. So when we hit them, they will break into pieces. You can see when you crush the table salt, sodium chloride, you will get fine powder of sodium chloride. Why? Because it is brittle. Because of the same reason, that is strong force of attraction between cation and anion, these have high melting and boiling point, and therefore it is very tough to overcome the strong interionic attraction. So large amount of energy is required, therefore they have high melting and boiling point. Now I want to give you one example. For example, we have sodium chloride, common salt, which is solid. Okay, now I'm heating it. Heating at a temperature which is higher than its melting point. So when I am heating sodium chloride above its melting point, your sodium chloride will convert into liquid, and we will be getting Na plus ion in the liquid state, and this is Cl minus ion in the liquid state. So this part is what? This is what we call as molten sodium chloride. So molten sodium chloride is basically a source of positive and negative ion which are free in the medium. This is molten salt or molten sodium chloride. Next property, these are soluble in water. Reason: water is polar solvent. Polar solvent means it is having two poles, positive and negative poles, and the logic is like dissolves like. So ionic compound or a polar compound is soluble in the same type of solvent. Therefore, because ionic compounds are made up of iron, they are soluble in water, which is having also some sort of ionic character. Okay, but it is insoluble in organic solvent like kerosene or petrol. Why? Because these solvents are not having any charge characteristic. Okay, So when we dissolve sodium chloride in water, we will be getting sodium ion and chloride ion. How to write down that equation? Here, your NaCl solid, and when we are dissolving it, the normal salt we are dissolving in water, we are getting Na plus ion and Cl minus ion again, like in the previous case. But here these ions are surrounded by water molecule, therefore we'll write aqueous here. AQ stand for aqueous. But idea is, again we are getting your free ions in this case, okay, not in liquid form, in the aqueous form. Next property, a solution of ionic compound, the same idea which I have explained here, we have given here also. That is, a solution of ionic compound in water contain ion which move to opposite electrode when electricity is passed through the solution. So this we have explained here, and with the help of this diagram. Here they have taken a solution of salt, that is called sodium chloride. Salt will be having what? Na plus ion and the Cl minus ion. So these ions will move to the opposite electrode. Positive ion to the negative electrode and negative ion to the positive electrode, because opposite charge will attract each other. Okay. So idea is, solid salt will not, even if it is an ionic compound, will not conduct electricity. But when we make a solution of any ionic compound, or we take ionic compound in molten state, then it is capable of passing electric current. Okay, so the idea is, if we want to pass electric current, either we take your solution of sodium chloride, that is this case, as we solution will be having oppositely charged ion, or we will take the molten state of your ions. So this is the idea. So this is for the properties of your ionic compound. Just a moment. We have depicted with the reverse color. Okay, fine. Next is, we will come to the metallurgy, how we are getting metal from their compound. We have seen from the chemical properties of metal that metals are very reactive. So in earth crust, they are not found in the mostly free state. Very metals of low reactivity like gold or silver, they are found in the uncombined form or the free state. Otherwise, metals are found in the combined state in the form of their compound, because they are very reactive. And most common compound of your metals are the oxide, because oxygen is available everywhere, and oxygen is highly reactive also. So sources of metal, we found metal in earth crust in the form of compound which we call as minerals, and some amount of these minerals are also found in the sea water. All compounds of metals are not useful to us. Only those compounds of metal from which metal can be extracted are useful to us, and they are called as ores. So ores are basically minerals containing high percentage of particular metal, and from which metal can be profitably extracted. So those minerals from which we can extract metal profitably, they are called as ores. All minerals are not ores. So in case of low reactivity or no reactivity metal which are least reactive, they are found in free state. These are the examples. And in combined state, we are having rest of the metals of very high reactivity or metals of the moderate reactivity. Copper and silver are of very, very low reactivity, but they are also found in combined state. So don't get confused. And ores of most of the metals are oxide. We discussed this earlier. So here we'll see the steps involved in the extraction of metal from ore. Before doing this mind map, remember basic idea. For the basic step for the extraction of metal is the first step, that is your concentration of ore. That is basically Purification of ore. The ore which is we are getting from different mines is having different dirt particles or the impurities. So first we have to clean it. So the cleaning process is the first step. That is cleaning of ore is the concentration of ore. Now after cleaning, second step, in few cases these ores are in the form of different compounds like sulfides, carbonates. So what we do, we convert ore into the oxide. Why? Because from oxide extraction of metal is easy. Third step is conversion of this oxide into metal. And the fourth step is the purification of metal, because this metal which is extracted from these steps will be having some impurities. So these are the basic steps, but these steps we will modify depending upon what type of metal we are extracting. Okay, so therefore in this mind map we have three different type of examples. So basic step, that is first step, is same in all types of metal. We know metals we divide into three different categories: metals of very high reactivity like sodium, potassium; metals of moderate reactivity like zinc, iron; and lastly metals of very low reactivity like copper and mercury. So depending upon what type of metal you are extracting, we will have a slight changes in these four steps. Fine. So the very first case, metals of high reactivity, like if we want to extract potassium or sodium, first step is same in every case, that is purification or concentration or enrichment of ore. Now in case of high reactivity metals, second step is what? Directly extraction of metal from the ore. That is direct process. That is in this case we will not do second step here, we will do directly this step. Okay, so therefore your extraction of metal is done directly, and it is done with the help of electrolysis process. Therefore it is called as electrolytic reduction, and from here we are getting pure metal. Okay, so in case of high reactivity metal we have only two steps. First is concentration or the purification of ore, next is the reduction of metal. Fine. Now in case of metals of medium reactivity like zinc, iron, lead and copper. Okay, here we will follow all four steps. First is purification step. Second step is the conversion of ore into oxide ore. Okay, so we will get oxide of metal, and for this we will follow two process. If your ore is carbonate ore, we will do calcination process to get oxide, and if your ore is sulfide ore, then we will do roasting process to get oxide ore. So finally we are getting oxide of metal. Now this oxide of metal will undergo reduction to metal, that is your third step. We have written here oxide to metal, third step. And finally the metal which is produced here, we will do purification of it, therefore last step. In case of last example, high reactivity metal, the metal which is obtained by electrolysis process is already of high purity, so there is no point of doing purification in that case. So we will do purification in case of these metals like zinc, iron, lead and copper. Now those metals which are of very low reactivity, so we will do the second step, that is conversion to oxide, that is roasting process. Then we will be getting metal, and lastly we will do the refining process or the purification process. Okay, so this is all about the brief idea how we will do the extraction process. Now we will discuss these steps one by one in detail. The first one is enrichment of ore. Enrichment means making your ore free of any unwanted particle, like that is removal of impurities, and impurities are called as the gangue particle. These may be like soil or sand or like pieces of rock, etc. So here the process which is used is based on difference in physical or chemical properties of your impurities and the ore. For example, in case of ores of iron, these ores are magnetic. So suppose Ore is magnetic and impurities are non-magnetic. So with the help of magnetic separation, that is, we utilize a strong magnet to separate ore from the impurities. So ore will be attracted towards magnet while impurities will not be attracted by magnet, therefore they get separated. So first step is done, that is enrichment of ore. Sometimes ore is heavier and the impurities are lighter. So we will remove impurities either by gravitation process or by decantation process. Extraction of metal of low reactivity or extraction of metal low in activity series. And in this case, the process for obtaining metal which we follow is called as thermal reduction. So metals of very low reactivity, they can be obtained simply by heating. Therefore, we call it as thermal reduction. Okay, why? Because they are not very reactive. So ores are reduced to metal by heating alone in the presence of air. In the presence of air, when we are heating anything, the process is called as roasting. In the absence of air or less supply of air, if we are heating, it is called as calcination. So, for example, in case of mercury, we have taken cinnabar is an ore of mercury, Hgs. The sulfide ore is heated, will get oxide ore, and then it will undergo reduction on strong heating to give you metal. So the steps are shown. Your Hgs, when heated with oxygen, you will get HgO. This HgO will be converted to Hg, that is mercury metal. So conversion of oxide to metal is called as reduction process because metal is undergoing reduction. How we will explain this idea here? Metal is in HgO, metal is in Hg2 plus form. So it is converted to Hg by taking electron. Okay. So this addition of electron is called as reduction. Therefore, it is being called as the reduction process. Similarly, we can show this in case of sulfide of copper. When we heat with oxygen, we will be getting oxide. And then this oxide is react with the sulfide which we have originally to give you copper metal. So again, second step is the reduction process. Next is extraction of metals of medium reactivity, means those metals which are neither very highly reactive or they are not of low reactivity like copper or silver or gold. So these metals, they are being reduced with the help of other compound like for example coke or other metals. So this is called as chemical reduction. So when any reducing agent is used, it is called as chemical reduction. Previously we have used heat only, so it was called as thermal reduction. So like ores of iron, zinc, lead and copper, they are basically either sulfide ore or carbonate ore. Okay. So therefore what we do, the sulfide ore or carbonate ore we convert into oxide because it is easier to obtain metal from oxide. Less resources and no extreme condition is needed if we are getting metal from oxide. So, prior to reduction, sulfide and carbonate ores are converted into metal oxide. This we do by two processes, roasting and calcination. You should be very much clear about the difference between roasting and calcination. In your exam, they can ask the difference between the two. So, the process of strongly heating sulfide ore in the presence of excess of air. Basically, when we heat any compound in excess of air or oxygen, we call it as roasting. And this process converts sulfide ore into metal oxide. Okay, like here we have shown in this example. And calcination is the process of strongly heating carbonate ore in the limited air to form metal oxide. So basically calcination is heating in limited supply of air or no air. Therefore, in the second equation, we have not shown here oxygen. Simply carbonate ore when heated strongly, it will form oxide. Okay, so be very clear about how we write down the equation in two cases. Roasting in excess of air, therefore we are showing in the equation oxygen gas, and calcination in limited air, therefore we are not writing oxygen in the second equation. So here, this once metal oxide is obtained, like here we get metal oxide, we get metal oxide. Now this metal oxide is converted to metal. So metal oxide is reduced to metal by suitable reducing agent, like for example carbon. Therefore we call it as chemical reduction. So your zinc oxide will react with the carbon to give zinc metal, and carbon will be released in the form of carbon monoxide gas. Okay, so here we are using carbon as a reducing agent. Sometimes reactive metals are also used as a reducing agent, like in this case aluminium is used as a reducing agent. Here also aluminium is used as a reducing agent. Okay, and what is the idea why these metals are acting as a reducing agent? Same idea. We will have displacement reaction. More reactive metal will displace less reactive metal from its salt solution. So here more reactive metal will displace less reactive metal from its salt solution. Okay. Now these two reactions are highly exothermic. Okay. Therefore, metal which is produced in these cases is in molten state. Have a look here. Here I have shown zinc in the solid state, but here I have shown manganese and iron in the liquid state. Why? Because medium is having high temperature, reaction is exothermic. Therefore, we show metal in the liquid state. So we will obtain solid metal by cooling down the liquid. Second reaction here, that is when iron oxide is treated with aluminium to get aluminium oxide. This process is called as thermite process, and this thermite process is used to join railway track, because here metal which is obtained is in liquid state. So between the two plates we will fill the liquid iron, and when it cools down it will solidify, and therefore we are able to join the tracks. So this is the application of this reaction. Now the third category, that is extraction of metal of high reactivity. That is those metals which are high in activity series. And for these metals, neither heat nor any reducing agent will be able to bring about reduction process. Therefore, we'll use here electrolytic reduction. That is reduction with the help of electrolysis. So metals of high reactivity, we cannot obtain by chemical reduction. Therefore, these metals, what we have, they are obtained by electrolytic reduction. Like for example, sodium, magnesium, calcium are obtained by electrolysis of their molten chloride. So what is molten chloride? Suppose here we have sodium chloride. So sodium chloride, this salt we heat till above its melting point, so we will get sodium chloride. Here temperature should be greater than melting point. Okay, and we'll get liquid sodium chloride. Liquid sodium chloride will be having positive ion and the negative ion in the liquid state. So positive ion will take electron to form metal, and the negative ion will lose electron to give you chlorine gas. So at cathode, where reduction takes place, you will get metal, and at anode, where oxidation takes place, you will get chlorine gas. So this is the electrolytic reduction process. Now next is refining of metal. We have obtained metal either by thermal reduction or chemical reduction or electrolytic reduction. Now this metal sometimes is impure. It is having some impurities. Therefore we have to clean it. This cleaning process we call as refining of metal. So metals obtained by various reduction process are not pure. So pure metal is obtained after refining process, and this is by electrolytic reduction. You have to be very clear. In your exam they can ask a short question that how to take pure and impure metal when we do the refining of metals. So in this case, impure metal in the form of a thick block is made as anode, and a thin strip of pure metal is taken as cathode, and the solution is of what metal salt solution is used as an electrolyte via which electricity is passed. So the first one is impure metal is used as an anode, and pure metal is used as cathode. Okay, be very clear about how we are doing. So let us come to this diagram. We have shown here an electrolytic tank, In this tank, we have taken copper sulfate solution. So here we have this blue color solution is of copper sulfate. So in copper sulfate solution, we will be having Cu2 plus ion and SO4 2 minus ion. Okay, oppositely charged ion. Now anode here is the electrode which is connected to positive terminal of the battery, and cathode is the electrode which is connected to negative terminal of the battery in the electrolysis process. Okay, so when we complete the circuit and we pass the current, anode which is positively charged at this reaction is what? Oxidation will take place. Copper metal from anode, which is basically impure metal. So this copper metal will undergo oxidation to give Cu2 plus ion, which will go into the solution, and electrons are released. They will be collected on anode, and from the solution, your copper ion will take electron from the cathode, which is negative electrode, to form pure metal at cathode. So your cathode will become thicker and thicker by the deposition of metal. Okay, so reduction will take place at cathode. So you have to be very clear. One idea, whatever is the sign of anode or cathode, one idea is always same or universal, is that we have oxidation process at anode and the reduction process at cathode. So this is all about electrolytic refining. Do remember this diagram, because in your exam they can give you any question related to this diagram. So you should be very much clear that at anode, copper metal is dissolving to give you copper ion in the solution, and at cathode, from the solution, ions are converting into metal, and this metal will get deposited on cathode. Therefore, with time, cathode will become thicker and thicker. Next, the topic is corrosion. This is the last topic for your chapter. So what is corrosion? Corrosion is slow deterioration or degradation of metal when exposed to certain environment. Okay, you have seen this in case of iron article or iron nail. When iron articles are exposed to moist air, they will develop a brown flaky substance on the surface. Okay, so this is what? The rust, and this rust is formed by the process of corrosion, that is slow degradation or deterioration of metal. So I have given you here 3 examples. You have to remember what type of coating or changes are there in case of specific metal. Like for example, if you have silver jewelry or the silver article, they will turn black. Their surface will become very dull and grayish or blackish. Why? Because when they are exposed to air, they will develop a coating of silver sulfide. In atmosphere, we have sulfur dioxide gas. So from that sulfur content will react with your silver article to form silver sulfide. Okay, and this silver sulfide is black in color. Therefore, their surface turn black. In case of copper, we'll get a green coating when the copper articles are exposed to the moist carbon dioxide in air. Air is made up of air is basically a mixture of different gases. So we have carbon dioxide also in the air. So this carbon dioxide content will react with copper to give you copper carbonate, which is green in color. Therefore, we get a green coating. Okay. Next is this copper carbonate is basic in nature. Why? Because it is a compound of a metal. Now next is iron. Your iron develops a brown flaky substance. You must have seen in different article in your kitchen. This flaky substance is what? Fe3O4. Okay, that we call this oxide as ferrous ferric oxide. And in moist air, if we are keeping iron article for a very long time, only then this rust is formed. So rust is basically ferrous ferric oxide. What is ferrous ferric oxide? It is basically a mixture of iron form 2 oxide, mixture of iron second oxide, that is FeO, and iron third oxide, that is Fe2O3. So it is a mixture of your ferrous oxide and ferric oxide. Therefore, we have written formula Fe34. So Fe3O4 is not a single compound. Basically, it is a mixture of two oxides, FeO and Fe2O3. Now, the idea of this rusting, or what are the conditions needed for rusting, we will discuss here with the help of this experiment. So in this experiment, they have taken 3 test tubes. In the first test tube, they have taken iron nail and water. They have dipped this iron nail in water, and simply after doing this arrangement, they have put a cork. So the test tube is having some here air, which was originally in the test tube. So this air is present here, and we have put some water also. So what we observe, after some time, there is a flaky rust formation in the test tube A. Why? Because both air and water are present here. That is ideal condition for the rusting process. That is, we need moist air. That is, moisture means water and air. Now in the test tube B, they have taken water, okay, here, but at the top of the water they have placed some oil. That is, oils, they form top layer on water. Water being of high density will be at the bottom, while oil is lighter, so it will float on the surface. So on the water there is oil layer. Therefore, this air which is there in the test tube, it is not able to come in contact with your nail. So air is not available here. Secondly, or you can say, oil is acting as a barrier between air and the nail. Next, we have taken here water, but this water is not normal water. We have boiled distilled water. Okay, so after boiling, all dissolved oxygen is removed from the water. So your water is without any oxygen. So this air is not coming in contact with water. Why? Because oil is acting as barrier, and water is also not having air. So test tube B is not having supply of air, or air is not coming in contact with the nail. Therefore, only water is available. Therefore, we will not get any rust here. Nail will not rust in test tube B. And in test tube C, we have taken again test tube and with a nail, but in this case we have not added water. So we removed one of the parameter. But you know, in our atmosphere, air is also having moisture in the form of water vapors. So those water vapors we will eliminate by putting a dehydrating agent like calcium chloride. So calcium chloride is a drying agent, so it will remove all suspended water molecule in the form of water vapor. So test tube C is basically having air but no water. So there will not be any rusting in B and C. Why? B is having water but no air. C is having air but no water. A is the only one which is having both water as well as air. Okay, so in test tube A, iron nail will rust. Why? Because exposed to both air and water. Test tube B, no rust, because exposed to water only. Oil layer will prevent air dissolving in the water. And test tube C, no rust. Okay, because exposed to dry air. So ideal conditions for rusting are moist air, that is air and water. Both should be present. So your corrosion is a degradation process. So it will damage our articles and utensils. Therefore, we should put a check on this. Therefore, we do some preventive measures. So preventions of corrosion. The different steps which we take are by simple method like painting. We cover the surface with a paint so that your article is not coming in contact with air. Or oiling, same idea. Painting and oiling act as a barrier method between air and the article. Greasing, galvanizing, chrome plating, anodizing, and making alloy. Okay, these three are very simple. All of you know this. But what is chrome plating? Chrome plating is what? Making a coating of chromium metal on the surface. Okay, so the metal which is inside is protected. Anodizing is we have discussed that aluminium article, when they come in contact with water at normal temperature, they form a protective layer of oxide which will stop further oxidation of metal. So this idea is utilized in anodizing process. What we do here, we form a thick oxide layer. The normal layer is very thin, which if we scratch, then it will get removed, but this layer we will make thicker in your anodizing process. So forming a thick oxide layer of aluminium, what we do for this, we take a clean article which is made as anode, and it is electrolyzed with dilute sulfuric acid solution. When we electrolyze dilute sulfuric acid solution, oxygen gas will be evolved at anode. So therefore oxygen will react with the article which is already present at anode. Okay, and we will get oxide layer at the surface of the article. So this is anodizing process. So anodizing is your process of forming a thick layer of oxide of aluminium. Okay, next is galvanizing. Galvanizing process, here we make a coating of zinc. A layer of zinc is made. In chrome plating, there was a layer of chromium. In anodizing, there is a oxide layer of aluminium, that is aluminium oxide, Al2O3. And in galvanizing, we make a layer of zinc. So here we have a layer of zinc. Now here one thing is very important to remember. Suppose we have an article which we have galvanized, and this article develop a scratch while using. So even if it is scratched, the article will not get damaged. Why? Because zinc is more reactive than iron. We have to remember this idea. So therefore galvanized article is protected even if the zinc coating is broken, because zinc is more reactive than iron. Therefore always zinc will get oxidized. Iron article which is inside will be protected. Okay, so three preventive measures which are very important are chrome plating, anodizing, and galvanizing. Now last idea which is used as preventive measure is alloy formation. Alloys are homogeneous mixture of two or more metals, or they are sometimes a mixture of a metal and a non-metal. And why we do alloy? When we form alloy, properties of metals are modified, and therefore we will put a check on the process of corrosion. Like for example, when iron is mixed with carbon, very small amount of carbon, we call it as steel, and this iron is not soft, it is hard and strong. Next is when iron is mixed with nickel and chromium, we call it as stainless steel. Why? It is very hard and it will not rust, that is, we will not get any stain on the surface. Simply idea, it will not undergo rusting or corrosion. Next is we can make alloys of mercury also, and these alloys are called as amalgam. And important point which is you should remember that melting point and the electrical conductivity of an alloy is less than that of pure metal. Okay, metal may be a good conductor, but its alloy will not be a good conductor of electricity. So we can have this example, like for example, when copper is used to form copper wire, which are used to make any electrical circuit. Why? Because copper is having high melting point and it is having high electrical conductivity. But here we are having two alloys of copper, like brass, where copper is mixed with zinc, and bronze, where copper is mixed with tin. They are not good conductors of electricity. Why? Because properties of alloys get modified. So electrical conductivity of alloy is less than that of pure metal. And the last one is an alloy of lead with tin. We call it as solder, and this alloy have very low melting point. Therefore, it is used in welding process. So this is all for today. I hope this chapter is clear. We will do NCERT exercise for the same chapter in the next video. This is all for today. Thank you.